we are going to be investigating the solubility of sugar at different temperatures. And we're going to make aqueous sugar water solution. Now the molecule, the sugar molecule, is actually sucrose. And the chemical formula for that is C12H22O11. So it's a pretty big molecule, covalently bonded molecule. Now there are a couple things that affect solubility when we talk about dissolving solids in water. The main thing is the polarity. See, the polarity of water molecules is polar. The oxygen side of a water molecule kind of pulls electrons more strongly. That makes it a polar molecule. And what that means is that in order for something to dissolve in water, it also needs to be a polar molecule. And it turns out that sugar is very polar. So things that would be nonpolar would be molecules that were more symmetrical, and they really wouldn't have the ability, the water wouldn't have the ability to pull them apart and dissolve them. Another thing affecting solubility is the size of the molecule. So how well that molecule dissolves in water is really affected by its size, and also pressure and temperature. So sometimes we see that warmer things affect the solubility of solids differently, and that's really what we're going to be investigating in this lab. The fourth thing that can kind of affect solubility is pressure. That's really only for gases, and since we're using sugar, dissolving sugar, we're doing a solid. We're going to investigate gases later on. So I've set up 3 water baths, and we're going to make solutions. So I've got a cold water bath, and the temperature of that is 12.6, 12.7. I've set up a room temperature water bath, and the temperature of that is 20.8. These are Celsius degrees, 20.8. And then I warmed up some water, and the temperature of the warm water is 44.5. So what we're going to do is create these 3 sugar water solutions, and we want to saturate it, which means we want to dissolve all of the sugar that water is possibly able to dissolve. At some point, no more solute will be able to dissolve in the solvent, and then we say that the solution is saturated. Saturation actually depends on temperature. So this is what we call a saturation curve. On the y-axis, you've got the number of grams of sucrose that's able to be dissolved in your water. And on the x-axis, we've got the temperature of the water. And this is something you would research and find out because it's going to be a little bit different for every type of solute. So this is the saturation curve for sugar. Okay, so let me find my temperatures on my x-axis and see if I can read my saturation points, and I'm going to draw on this a little bit and get right back to you. So we're back with our graphs, and I looked at my temperature data, and I marked the different temperatures. I had a cold temperature, a room temperature, and a warm temperature. So I just marked those on my x-axis, and then I did what's called interpolate, which means I drew a line up, I hit my saturation curve, and then I drew a line to the left, and that told me about how many grams of sugar it would take to saturate my solution at that temperature. So I repeated that process for the room temperature and for the warm water. So interpolate up, hit your curve, and then do a straight dash line over. And what I found out was that for my cold water, I'm going to need about 180 grams of sugar to saturate it. For my room temperature water, I'm going to need about 200 grams of sugar to saturate it. And for my warm water, I'm going to need about 230 grams of sugar to saturate it. So my next step is going to be to weigh out that amount of sugar. Alrighty, so here I have my electronic balance where I'm going to weigh my sugar, and it's quite a bit of sugar. So I would normally use a little weigh boat like this, but I'm going to need a lot of sugar. So I'm going to use these little plastic beakers. Okay, so I'm going to put that on the balance. I don't want to record the weight of the container. So I'm going to hit this tare button, or 0 button it's called. And that sends my balance to 0. And then I'm going to start adding in my sugar. So this is the cold water bath. And according to my saturation curve, I need 180 grams. This really seems like a lot of sugar. So it's going to be interesting to see if all of this actually dissolves. Oops, too much. So I got to go back and forth a little bit here. Take out a little bit. Add a little bit back in. And just try to get as close to 180 as I can. Oh, I'm so close. Okay. Ah! All right, I'm happy with that. All right, and I've already weighed out the other 2 amounts. So the 180 grams and the 200 grams and the 230 grams. So here is what they look like. 180, 200, and 230. So that's quite a bit of sugar. And in the next step, we are going to put these in our beakers and stir, 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 and see if we can get our solution saturated. Alrighty, so here goes my first sample. Wow, that's a lot of sugar. Let me stir that a little bit. And we're gonna find out if this saturation curve, that looks like it's dissolving pretty well. You'll know it dissolves because it'll turn clear. So I'm going to put in a little bit more. This is going to be unbelievably sweet. If you were to make sweet tea out of this, it would be disgusting. But I know people that drink sweet tea that's this sweet, honestly. Maybe we should write a solubility lab to create something we can drink. So I'm going to repeat this process for my other 2 beakers. This was the 180 grams of sugar added to my cold water beaker, and you should have that temperature already. Alrighty, and now let's do the 200 grams. So this is going into my room temperature water. La 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 la. Okay, and I don't just dump it in all at once. I put in you know, a good chunk. I stir it a little bit. So this takes patience, and I do have some machine little tools that I use to stir solutions. It could take anywhere from 5 minutes to 2 hours to really dissolve well. So I'll probably let this sit for a while and stir it periodically and see if I can get it all dissolved. Okay, so that's everything in the room temperature beaker. And last, we're going to do the warm water beaker. Half, stir, stir, stir. And I had to adjust the temperature of this one because as I was recording videos, it cooled off. And I had to add a little more ice to my cold one too because it warmed up. So I kind of had to fiddle with it to maintain the temperatures. All right, ooh, that's a lot. All right, so this one, hopefully, that will saturate. I might have oversaturated these, but I tried to be as exact as I could with interpolating the data off of my solubility curve. So we shall see. All right, so I'm going to let these work and stir, stir, stir. And we'll come back and look at them in a little bit and see if all of that sugar has dissolved to create saturated solutions. So it's been about half an hour since I put my sugar water in and started stirring, and I got really tired of stirring. So I actually set up my little electronic stirrer, and it's just a stir function, and then you drop a little magnet into your solution, and it rotates the magnet around and stirs it at the bottom, so you can kind of see that magnet in there. So I just have my 3 beakers on there, and that's been stirring a little while, and I can see that they're a little bit less cloudy than they were, which tells me that the sugar is is slowly dissolving in them. So I'm going to call those solutions saturated. They might be oversaturated, but I'm going to call them saturated. You guys are going to record your temperature data, your mass of solute data. You're going to convert the grams of each of the solute into moles. And then you're going to calculate the molarity of these three solutions. So this has been your solubility versus temperature of sucrose lab. Thank you for joining me.